Okay, so today I'm going to talk about some issues I've spotted with TLS resumption in Jetty. Now, I could kind of show our embedded product to kind of really highlight the problem, but what I'm doing here to try and isolate the problem down is I'm using stock Jetty. I'm using it on our embedded platform, but you could run this from Windows as well. It's the same. I've seen the same issue repeated again and again, and it seems to have existed for quite a while. And I'm not sure this is something that would show up just using the OpenSSL tool that some people kind of use to kind of prove resumption. What I'm going to use is Chrome and Wireshark with the current configuration I have. Just a tip before we get started for configuring Wireshark. If you do have Jetty configured on a different port, say not 443 for HTTPS but for something else, go to Edit, then go to Preferences, go to Protocols, and go down to HTTPS, HTTP, sorry, and then in the SSL TLS ports, you can add your other ports that you've got there. If you haven't got that, when you try and look at the SSL traffic, it won't show up, and that's a real pain. So make sure you've got that. You might need to restart Wireshark in order for that to happen. Okay, so what I'm going to do now is, as I said, this is a stock Jetty. It's version 9.4.5, I think. I've just downloaded it and enabled the overlay demo base on top. And just added a few HTML and images to show how it works. So what I'm going to do is go to my page now, and we'll see Jetty kind of flood with some, Wireshark show the SSL traffic. Okay, now I had already loaded this page, so it's not doing the full renegotiation there. But if I scroll down, you can see in the traffic we've got quite a few client hellos happening. Actually, quite an abnormally high number of client hellos. If I go and find here the ones which I noticed which was causing the kind of performance problem with is the TLS handshake, because on an embedded platform that actually calls secure random, and there's a certain amount of entropy that has to build up when you call secure random. So it was being called quite a lot and quite unnecessarily as well. So that handshake using quite a few resources instead of using the resumption, which was a bit of an issue for us. So if I've loaded that page once, and what I'm going to do now is I'm going to wait 60 seconds. And the reason I'm going to wait 60 seconds is some of those sockets that are open, there's a 60-second timeout. So I'm going to let them time out. So when I refresh the page again, it will open those sockets up again, and we should see some more client hellos. And that's kind of where I want to highlight the problem. Now, before I hit the refresh button there, I'm just going to find a client hello, ideally a server hello really, so we can kind of work out what the current ID is, session ID there. So go copy value, and I've just made a note of the session ID, and if everything is working correctly, that session ID there and the TLS session ID should remain constant because it should be cached by the client. The server should have that cache too there, and they should be able to pick that up and carry on using it. So that's going to, as I'm going to show, this is the thing that's going to be changing. So that's about 60 seconds. What I'm going to do now is just hit refresh on the browser and have a look at the traffic here that's getting generated. So when I look down this traffic, you can see here all of a sudden what's going on here. We've got some server key exchange messages happening. Okay, and this is basically doing the full handshake again, just on a simple browser refresh there. Unless I'm mistaken, I could be mistaken. I don't think I'm not a TLS expert in this, but what we can see here is when we have a look at this, we can take a look again at the TLS session IDs. You can see it's actually different. So the the TLS session ID is changed, and there's a reason for that change, and I think I've identified where it is. One nice thing about Wireshark is that I can actually kind of step through a flow on a particular stream. So if I do this on this particular one, for instance, I can kind of follow the TCP stream, and this one seems to be largely okay, but you can see here client hello, you can see the server hello, what it's coming back with, and we've got the data until it closes here. So that one's okay. You can see it's doing the full key exchange. After that, it's working okay. But why? I guess the question is, why is it having to do that full key exchange in the first place there? So if we take a look at that again, okay, and I was here, okay. If we now what we'll do is we'll get rid of the SSL filter, and we'll actually see where these sockets are being closed, because actually there's a pattern happening here. So if I go, you can see these sockets are being closed here, and if I actually take a look how they're being closed, this sums it up here. So you've got the this is a very, very short-lived number of requests here. It's kind of like trying to open and it kind of get closed down. Okay, so the client hello happens here. Let's take a look at the IDs. So we've got copy value, right? And then we'll take a look what value we've got here. So that's 72. All right, let's see what the server comes back with in this case. So copy value here. That's 72. That's fine. And then, but you can see quite quickly that the connection is being closed. Okay, so let's just keep on that one there. Highlight that one. Let's go back to our stream of data. Okay, so which is the one I had selected? Right, that's the one I had selected there. So that's 114. Now, if we look at one of the later requests that actually go out, we can actually see that the server after this is going to, because that connection is being closed, so at a later date on one of these, we had that connection closed, and later date on one of these, we can view a slightly later time, 174, the client hello. So if we do this now, and we follow this TCP stream, we can see that the client hello, and this client hello here, we had that last request open and shut very quickly, and I believe what's happened there is that's completely invalidated the TLS session, and then the browser's trying to open a connection again, and this time it's using the same session ID, so it's trying to use this session ID. And we should be able to prove this by just having this copying the client hello here. So it's the session ID we've got. So we've got copy, value, and then 72. But the server comes back with value. Because it's doing a full handshake here, we should see actually come back with something different. Which it does. So it's changed. So I think what's happening here is in the code, what I've seen in my experiments. Now I realize that there's been some code written to kind of prevent TLS truncation attacks, but what I found is with my experiments, if I comment these two lines out here, and this is in SSL connection, so that's org.eclipse.jetty.io.ssl.ssl connection. If I comment out these two lines here, it all works. Okay, basically I can see the resumption working. I don't see the constant key exchanges happening in Chrome. By the way, this The Chrome version I'm using here is just the latest Chrome. Nothing special about it. It's you can use the latest Firefox. It doesn't make any difference. But if I comment these two lines out on 547 and 548, it all seems to work for me. Now, okay, that's nice, but I realize that, is this reintroducing a security vulnerability or not? I'm not sure. So that's why I'm bringing it up with the Jetty team to kind of take it from there. But it's quite easily reproducible with the right tools. Thank you.